In 1970, 11% of people in certain region completed 4 years of college. 40% of them were women. In 1990, 23% of people in the same region completed 4 years of college. 52% of them were women. Complete parts A through C. Given that a person completed 4 years of college in 1970, what's the probability that the person was a woman? So that's just a straight up given information to us. We're talking about 1970, and they say that even this 11% is not relevant for this part. They say 11% people completed 4 years of college, 40% of them were women. So basically, they're telling that among the people who completed college, 40% were women, and that's exactly what they're asking. Given that a person completed 4 years of college, what's the probability the person was a woman? And that's 40%, 0.4. What's the probability that a woman finished 4 years of college in 1990? So in 1990, uh, to finish 4 years of college, you first have to have 4 years of college, which is 23%, and then you have to be a woman, and 52% of that were women. Um, so we can directly use the multiplication rule. So we have probability that you completed the college, which is 0.23, and then times the probability that you were a woman who completed the college. So that's 0.52. And that comes out to be, let's calculate it, 0.23 times 0.52 is 0.1196. Now, if you're thinking in terms of conditional probability, then it would be the formula probability women given college. So that would be probability women and college divided by probability of college. So women given probability of being a woman, given that you completed a college degree, that's given to us. 52% of the college completers were women, so that's 0.52. And probability of being a woman and completed college, that's what you have to find. And probability of completing a college in that second year was 0.23. And that's how you see the 0.23 gets multiplied on the other side. And that's what we were doing if we were directly using the multiplication rule. And the answer is 0.1196. Let's just omit the other parts. What's the probability that a person was not male college graduate in 1990? So probability of not being male graduate. So not being male graduate can happen in two ways. One is that you're not graduate at all, so not graduating. Then, of course, since you are a non-graduate, therefore you are also a non-male graduate. And you could also be a female graduate, so female graduate. So not being a male graduate can occur in two ways. One is you're not a graduate at all. And another way is that you are a female graduate. And these are the two options that make up being not a male graduate. So not graduating is, so the graduating probability in 1990 is 23%. So not graduating would be 1 minus 0.23. That's the probability of not graduating. And the probability of being a female graduate which we already found in part B, is 0.1196. So 0.1196 plus 0.77, which would be 0.8896. Okay. A town has 4 fire engines operating independently. The probability that a specific engine is available when needed is 0.81. What's the probability that no engine is available when needed? So let A be the event A that an engine is available. It's event that an engine is available. So let N be the event that an engine is not available. Okay, so we're given that P of A is 0.81. So P of N of not being available will be 1 minus 0.81, because being available and not available are complementary events. So 0.19. And when they say probability that no fire engine is available, it means none of these 4 is available. So we want probability first is not available, second is not available, third is not available, and fourth is not available. And this is just multiplication rule. One of them not being available is 0.19, second not available 0.19, and third not available 0.19, and fourth not available 0.19. So basically it's 0.19 to the power 4. And we need 4 decimal places, so 0.0013 is what I get. The probability that a fire engine is available when needed. So what they are saying is that at least one of the engines is available. That's what they mean by a fire engine is available. So probability that at least one is available is the complement of none of them being available. So uh, the event that at least one of them is available is complementary to the event that none of them is available. So probability at least one available would be 1 minus probability none is available. And the none is available was calculated in part A. So that's 0.9987. Okay.